Alright students, so today in this video we are going to look at compositions of transformations. And what that means is basically we have more than one transformation. So it could be a reflection followed by a translation, it could be a rotation followed by a reflection. So if it's two or more transformations, then we call that a composition of transformations. So here we have an example. We have triangle ABC, and it's going to be reflected on the y-axis, followed by a translation with a vector -2, -4. The vector form is basically this right here, but I can also write it in this format. As you recall from a few chapters ago, I can have it in this format, and it's the same thing as the vector form. So when we do a reflection on the y-axis, recall that the only values that will change are the x values. So if I flip it on the y-axis, a prime is -2, 3, b prime is -3, 1, c prime is -1, -2, 1. And then if we do a translation of -2, that means I have to move everything to the left 2 units and then down 4. So it's going to be somewhere down here. That's a terrible triangle. We can do better than that. Let's do this one. And so we're going to call this A double prime, B double prime, C double prime. The double prime is stating that this was transformed twice. Notice here, my first transformation, single prime, double prime. That's a double transformation. So if I go to the left 2, and then this becomes -4, down 4, that becomes -1. The B prime is -3, 1, so if I go to the left 2, that becomes -5. And if I go down -4, that's -3. C prime is -2, 1, so if I go -2 minus 2, that's -4. And then I have 1 minus 4, which is -3. So this right here is an example of a composition of transformations. It was first reflected. Remember, this distance will be equidistant to that point. And then we had a translation, 2 units to the left. So 1, 2, and then down 4. 1, 2, 3, 4. I hope this makes sense. Let me know if you have any questions. We do have another example here. Let's say we have some parallel lines. Let's say that I'm going to call this line L, and this line here is, let's call it M. And let's say that those two are parallel. And if I have a shape here, let's call it, well, it's a point A here. If I reflect this on line L, it's going to be somewhere right here. It's going to be A prime. If I reflect it again on line M, it's going to be A double prime. 2 reflections on parallel lines is the same thing as if I do a translation. And so let's say that from L to M is 2 units. What is the distance between A to A prime? What's that distance? Well, the answer is going to be 4. This is equal to this distance plus that distance. So altogether, that's going to be 4. let's say I have an angle that it's 30 degrees here, and I have a point here. Let's call this, let's call it B. If I reflected over this point, over this line, let's call this line NO. If I reflect B over line N, this becomes B prime. And then if I reflect that once again over line O, this becomes B double prime. So two reflections here on this angle is the same thing as an entire rotation, a rotation of double that angle. Double that angle will be 60 degrees. So a reflection over line N, a reflection over line O is the same thing as a rotation around that angle. And the answer, it would be a rotation of 60 degrees about this point. This is pretty much all that you have covered yesterday, and you will cover tomorrow. Please let me know if you have any questions. Good day, everyone.